Okay, so today we're going to be solving systems of equations with the elimination method. It's another algebraic method that's similar to the substitution method, except this time you're going to be given equations in standard form. So notice that none of the equations say x equals or y equals. You have your x's, your y's, your equal sign, and then number. Everything's pretty much lined up. So x's, y's, equals, and numbers. This is how you know you're going to use the elimination method. So your goal is to look for opposite coefficients. Coefficients are the numbers that are in front of the x's or the y's. So notice that here in front of the x's we have a 1, and in front of the y's we have positive 1 and negative 1. Opposite means that one number is positive and one number is negative. So these are both the same, but since they're both positive, that's not opposite. Here we do have opposite coefficients. So right away we've got opposite coefficients. We don't have to do step 2 because we already have our opposites. So we could skip to step 3. Add the equations together. 1x plus 1x is 2x. 1y plus negative 1y is 0. These are going to cancel out, so no more y's. I have my equal sign, and 12 plus 4 is 16. Once my variable cancels out, I have only x's left, so you go ahead and solve that, and I've got x equals 8. So now I have the first variable. I'm going to use substitution. I could substitute it into either the top equation or the bottom equation. It doesn't matter which one. So I'm just going to go into the top. So it originally said x plus y equals 12. I know that x is 8. So I will undo the plus 8 by subtracting, and I get y equals 4. My final answer is an ordered pair. So it's 8, 4. And make sure you put it in the right order. So x always goes first, y always goes second. This is your typical solution, something where you have two straight lines that intersect at a single point. So this would be like if you had lines like this and they cross at one point. It is possible where you'd have a special case where you'd have parallel lines that never cross. That'd be this situation. Or you could have two lines that are directly on top of each other, and that would have infinitely many solutions. All right, but this one won't show up as often. Okay, so now we're going to move on to problem 2. We're looking for opposite coefficients. 3 and 6, those are not the same number. 4 and 3, those are not the same number. We have a negative one and a positive one, but they wouldn't cancel out to 0 if we were to just add them together. So in this case, we're going to look for opposites. We don't have that just yet. I'm going to multiply one of my equations so that I can get opposites. So the easiest way to do it is if you can realize that if you multiply 3 by negative 2, you're going to get the opposite of 6. Now, if you don't see that, another way you could do it is you can multiply both equations. So we could do it this way. Multiply the top equation by 3 and the bottom equation by 4. If we do that, that means everything in the top equation, make sure you distribute, has to be multiplied by 3. So we have 9x minus 12y equals negative 30. In the bottom equation, we have 24x plus 12y equals negative 168. All right, so if you notice now my opposite coefficients are the positive 12 and negative 12. All right, so now I'm going to add together. I get 33x equals negative 198. So now I'm going to divide. And I get x equals negative 6. All right, so go back, substitute it in, let's say the top equation, 3 times x minus 4 times y equals negative 10, and I'm going to put in my negative 6. So I have negative 18 minus 4y equals negative 16. Add 18 to both sides, and I get negative 4y equals 2. So if I divide both sides by negative 4, I get negative 1/2. All right, so my final answer is negative 6, negative 1/2. Now, I would say that that's probably the hard way to do the problem. You could also have done it, if you go back to the very original problem, we're just going to do this one again. I could have just multiplied the top equation by negative 2, and that would have eliminated my x's right away. So if I multiply that by negative 2, I would have gotten negative 6x plus 8y equals 20. And now I could just add right away instead of having to multiply both equations. I could cancel out the x's, get 11y equals negative 22, and y equals negative 2. Sorry, this is a 10, not a 16. So this should have been 8. Okay. My mistake. All right, that makes more sense. So now I'm going to go back and substitute into, let's say, the bottom equation. 6x plus 3 times negative 2 equals negative 42. So I have 6x minus 6 equals negative 42, and 6x equals negative 36, and x equals negative 6. So again, my final answer is obviously the same as, well, what I should have gotten originally. So I get negative 6 comma negative 2. This is probably the harder way because you had to multiply 2 equations, but here you only had to multiply 1 equation. All right, so let's flip to the next page. And I'll try to leave the steps up there for you to see. All right, so you're looking for opposite coefficients. 4 and 6, they're not opposites. 5 and 2, one's positive and one's negative. All right, so I would just try to get 5 and 2 to be the same number. Well, they both go into 10, so how can I make this say 10? I multiply it by 2, and here I multiply by 5. So I'm going to distribute. Make sure you multiply everything by 2. So 8x minus 10y equals 26, and 30x plus 10y equals whatever 48 times 5 is, which is 240. All right, once I have opposite coefficients, I'm going to add my equations together. And if you do that, one of your variables should cancel. So I have 38x equals 266. Then do 266 divided by 38, and you get x equals 7. So now substitute that back into either of the equations. It doesn't matter which one. So 4 times 7 minus 5y equals 13. 28 minus 5y equals 13. If you subtract 28 on both sides, you get negative 5y equals negative 15. And y equals 3. All right, so final answer is 7, 3. All right, last problem. We've got 10 and 5. Well, I can make this say 10 if I multiply by 2. However, if I just multiply by 2, that's only going to give me positive 10. Right? I don't want 10x. I need it to say negative 10x, so I need to multiply by negative 2. So I would get negative 10x minus 6y equals positive 24. The top equation you don't have to change at all. Now we get our opposite coefficients. So add the 2 equations together, I get negative 8y equals 40. And if I divide by negative 8, I get negative 5. And then at this point, you can either substitute the equation, the negative 5 into this equation, or the new one that you have. So pick any one. I'll just go with this one because it has the smallest numbers. So 3 times negative 5 is negative 15. And if I add 15 to each side, I have 5x equals 3, and x equals 3/5. So for all of these problems, I ended up just getting one single point where the 2 lines cross. And you have ordered pairs for your final solutions.